Hello there, you're listening to the planet's memory, where time breathes and the earth remembers. Beneath your feet, beneath the soil and stone, beneath the deepest oceans and the tallest mountains, beneath everything you have ever known or touched or seen, there lies a mystery so profound that it challenges every assumption humanity has ever made about the world we call home. 4,000 miles down, past layers of rock that have never seen sunlight, past temperatures that would vaporize steel in an instant, past pressures that would crush diamonds into dust, there exists a sphere of molten iron and solid crystal spinning in the darkness. We call it the core of the Earth, and for centuries we have accepted it as a natural formation, a product of cosmic accident and gravitational forces. But what if we have been wrong all along? What if the very heart of our planet, the engine that generates our protective magnetic field, the dynamo that shields us from the deadly radiation of space, the force that keeps our continents moving and our oceans churning, what if all of this was not an accident of nature but a deliberate creation? What if someone or something designed the core of the Earth, engineered it with purpose and precision, built it to sustain life on the surface for billions of years? Tonight, as you settle into the comfort of rest, as your mind begins to drift between waking and sleeping, we invite you on a journey into the deepest mystery our planet has ever held. This is not a tale of simple geology or straightforward science. This is a story that will take you through ancient legends and modern discoveries, through the minds of brilliant scientists and the visions of mystics, through evidence that has been hiding in plain sight for generations. Let the worries of your day dissolve as we descend together into the impossible question that may redefine everything we thought we knew about Earth, about humanity, and about our place in a universe far stranger than we ever imagined. The story begins not in a laboratory or a university, but in the quiet moments when humans first looked at the ground beneath them and wondered what lay below. Long before the age of science, before telescopes and microscopes, before we could peer into the atom or send probes to distant planets, human beings felt the earth move beneath their feet and knew that something powerful lived in the depths. Ancient cultures around the world developed remarkably similar stories about the interior of the planet, tales that spoke not of empty caverns or simple rock, but of intelligence, of design, of purpose. The ancient Sumerians, whose civilization emerged in Mesopotamia more than 5,000 years ago, wrote of the Anunnaki, beings who came from the heavens and worked deep within the earth, shaping something they called the foundation of the world. Their texts, preserved on clay tablets that survived millennia, describe these beings as masters of the deep earth, capable of channeling energies that modern readers might interpret as geological or geophysical forces. But the Sumerian texts suggest something more deliberate, more intentional than natural processes. They speak of the Anunnaki establishing a great engine in the underworld, a mechanism that would maintain balance and order for the surface world above. Halfway around the world, without any known contact with the Sumerians, the ancient Vedic traditions of India told strikingly similar stories. The Vedas, among the oldest religious texts in human history, describe the earth as having 7 layers, with the deepest layer containing what they called the cosmic egg, or the seed of creation. This was not merely poetic language for these ancient peoples. The text described this central seed as something that continuously gives birth to energy, as something that was placed there by the gods to ensure the earth would remain alive and fertile. The Sanskrit word they used, Hiranyagarbha, literally means golden womb, and the descriptions suggest not a passive geological feature but an active, almost technological system designed to perpetuate life. The Vedic scholars who studied these texts in ancient times understood them as describing something engineered, something built with intention by intelligences far beyond human comprehension. They spoke of this core mechanism as being maintained by divine beings, tended like a great fire that must never be allowed to go out, protected by layers of earth and stone from those who might interfere with its operation. the indigenous peoples of the Americas developed their own profound understanding of the Earth's interior, and their stories too suggest something far more purposeful than random geological formation. The Hopi people of the American Southwest have maintained oral traditions for thousands of years that speak of previous worlds that existed before this one, worlds that were destroyed when humanity lost its way. But central to all these stories is the concept that each world, including our current one, has a heart, a living core that was placed there by the Creator and the spirit beings who assist in maintaining cosmic order. The Hopi describe this heart as not merely physical but as having consciousness, as being aware of everything that happens on the surface, as being capable of responding to human behavior. When the people live in harmony and balance, the heart beats steadily and the world remains stable. When humanity falls into chaos and conflict, the heart becomes disturbed, and the earth itself reacts with earthquakes and volcanic eruptions. This is not primitive superstition, but a sophisticated understanding that frames the Earth's core as an engineered system with feedback mechanisms capable of sensing conditions on the surface and adjusting its output accordingly. Even more intriguing are the stories from Australia, where the Aboriginal peoples, whose continuous culture stretches back more than 60,000 years, maintain songlines and dreamtime stories that describe the creation of the world in terms that sound remarkably like engineering projects. The rainbow serpent, one of the most important figures in Aboriginal cosmology, is said to have travelled beneath the earth during the creation time, forming the landscape from below, creating the structures that would allow the land to support life. But the rainbow serpent did not merely carve out rivers and valleys. The stories describe this being as installing something in the deep center of the earth, something that would continue to work long after the creation time ended, something that would ensure the land remained connected to the sky, that the seasons would continue, that life would persist. The Aboriginal elders who kept these stories alive described this central installation as being alive in its own way, as having a song that those with the proper knowledge could hear, a vibration that spread through the entire earth and connected all living things. These ancient stories might be dismissed as mythology, as primitive attempts to explain natural phenomena without the benefit of scientific knowledge, except for one remarkable fact. When modern geologists and geophysicists finally developed the technology to study the Earth's deep interior in the 20th century, what they discovered was far stranger and more puzzling than they had anticipated. The scientific story of understanding the Earth's core begins in the late 1800s, when scientists first realized that the planet must have an interior structure far different from the surface we walk on. Early geologists noticed that earthquakes produced waves that traveled through the Earth, and by studying how these waves moved, they could make educated guesses about what lay below. In 1896, a scientist named Emil Weichert proposed that the Earth must have a heavy iron core based on calculations of the planet's overall density. This was revolutionary thinking at the time, because it meant the Earth was not a solid ball of rock, but had distinct layers with different properties. The real breakthrough came in 1906, when a British geologist named Richard Dixon Oldham studied seismic waves from a major earthquake and noticed something remarkable. Some waves passed through the Earth and arrived at distant seismic stations, but they arrived later than expected and from slightly different directions than predicted. Oldham realized that these waves must have been bent as they traveled through the Earth's interior, which could only happen if they passed through a layer with very different properties from the surrounding rock. He concluded that the Earth must have a liquid core, a vast ocean of molten material deep inside the planet. This discovery stunned the scientific community because a liquid core raised enormous questions. What kept it liquid at such enormous pressures? How had it formed? What was it made of? And most importantly, what effect did this churning sea of molten metal have on the world above? Over the next several decades, scientists gradually built up a more detailed picture of the Earth's interior. They discovered that the core was not a single uniform layer, but consisted of two distinct parts. The outer core, extending from about 1,800 miles deep to about 100 miles deep, was indeed liquid, composed primarily of molten iron with some lighter elements mixed in. But at the very centre, at depths greater than 3,100 miles, the pressure became so intense that the iron was squeezed back into a solid state, forming what scientists called the inner core, a sphere of crystalline iron about 1,500 miles in diameter. This inner core was not just any solid mass, but appeared to be a single gigantic crystal, perhaps the largest crystal in the entire solar system, spinning within the liquid outer core like a planet within a planet. The temperatures in this region exceeded 9,000 degrees Fahrenheit, hotter than the surface of the Sun. Yet the immense pressure kept the iron solid despite the heat. As scientists learned more about this hidden realm, they discovered something even more remarkable. The liquid outer core was not just sitting there passively. It was moving, churning, flowing in complex patterns, driven by the heat escaping from the even deeper inner core and by the rotation of the Earth itself. This movement of electrically conductive molten iron created electrical currents, and these electrical currents generated a magnetic field. This was the source of Earth's magnetic field, the invisible shield that protects the surface from the deadly solar wind and cosmic radiation that would otherwise strip away our atmosphere and sterilize the planet. Without this magnetic field, Earth would be a dead world like Mars, which lost its magnetic field billions of years ago, and subsequently lost most of its atmosphere and any surface water it once had. The Earth's core, then, was not just a geological curiosity, but the very reason life could exist and persist on the surface. It was quite literally the engine that made Earth habitable. But as scientists studied this remarkable system more closely, they began to notice things that did not quite fit the simple story of natural formation. The first puzzle was the sheer efficiency of the geodynamigo, as scientists called the magnetic field generating mechanism. Computer models showed that creating a stable, long-lasting magnetic field like Earth's required a very specific set of conditions. The composition of the core had to be just right, with the correct mixture of iron and lighter elements like sulfur, oxygen, or silicon. The heat flow had to be carefully balanced so that convection in the outer core continued at the right rate. The rotation rate of the planet had to fall within a certain range. The size of the inner core relative to the outer core had to meet certain criteria. When scientists plugged random values into their models, they almost never got stable magnetic fields. Most parameter combinations produced either no magnetic field at all, or wildly fluctuating fields that would flip polarity every few thousand years, exposing the surface to dangerous radiation during the transitions. Yet Earth has maintained a relatively stable magnetic field for billions of years, with only occasional reversals separated by hundreds of thousands or millions of years. The odds of this happening by chance seemed remarkably small. The second puzzle involved the inner core itself. When scientists studied seismic waves that passed through the inner core, they discovered that it was not uniform. The seismic waves traveled faster in one direction, from North Pole to South Pole, than they did in the east-west direction. This anisotropy, as scientists called it, suggested that the iron crystals making up the inner core were aligned in a specific pattern, all oriented in the same direction like iron filings near a magnet. But how could this alignment have come about? In a naturally formed core, you would expect the crystals to be randomly oriented, pointing in all different directions. Some process had organized them into this uniform alignment. Scientists proposed various natural mechanisms that might account for this, such as the flow patterns in the outer core or the stress from the Earth's rotation, but none of the explanations worked quite right. The alignment was too perfect, too complete, as if the inner core had been deliberately organized into this configuration. The third puzzle was even stranger. In the late 1990s, Scientists discovered that the inner core was not locked in place but was actually rotating at a slightly different rate than the rest of the planet. The inner core spun faster than the mantle and crust above it, gaining about 1 degree per year relative to the surface. This meant that the inner core completed an extra full rotation every 360 years or so compared to the surface. Why would the inner core rotate at a different rate? What mechanism kept it spinning at this precise differential speed? The liquid outer core provided some lubrication, allowing the inner core to rotate independently, but something had to be driving this rotation, maintaining it against the friction and magnetic coupling between the inner and outer core. Scientists proposed that the flow patterns in the outer core pushed the inner core along, but the mathematical models were complicated and never quite produced the observed rotation rate without some fine-tuning of the parameters. A fourth puzzle emerged from studies of the Earth's magnetic field itself. The field was not static but changed over time in complex ways. The magnetic North Pole wandered around, sometimes moving dozens of miles in a year. The overall strength of the field varied, sometimes weakening to half its normal strength before recovering. Every few 100,000 years, the field underwent a complete reversal, with north and south magnetic poles swapping positions. These reversals seemed to happen at irregular intervals, with sometimes several million years passing between reversals and other times just tens of thousands of years. Scientists could see evidence of these reversals preserved in ancient lava flows, where magnetic minerals recorded the direction of the magnetic field when they solidified. What they found was puzzling. The reversals did not follow any obvious pattern or cycle. They seemed almost random, yet there were hints of structure in the data, suggestions that something was controlling or at least influencing when reversals occurred. If the geodynamo was purely a natural chaotic system, you would expect completely random behavior, but the actual pattern of reversals had subtle regularities that suggested some underlying order. Perhaps the most disturbing puzzle came from calculations about the age of the Earth's magnetic field. Scientists could use various dating methods to determine when certain rocks formed and whether they contained magnetic minerals that recorded the presence of a magnetic field. These studies showed that Earth has had a magnetic field for at least 3.5 billion years, possibly longer. But calculations of how much heat was available to drive convection in the core suggested that the geodynamo should have shut down long ago. The Earth has been slowly cooling since it formed 4.5 billion years ago. As it cools, the heat available to drive convection in the outer core decreases. At some point, convection should stop, the geodynamo should turn off, and the magnetic field should disappear. According to some calculations, this should have happened 1 billion or 2 billion years ago. Yet the magnetic field was still here, still strong, still protecting the surface. Something was providing additional energy to keep the geodynamico running. Scientists proposed that the gradual freezing of the inner core, which released heat and caused lighter elements to float upward in the outer core, provided this extra energy. But the calculations were delicate and required the core composition and cooling rate to fall within very narrow ranges. Once again, it seemed like the system was fine-tuned, carefully balanced to maintain the magnetic field for billions of years. These puzzles might have remained mere scientific curiosities, interesting problems for geophysicists to ponder, but not particularly relevant to the average person, except that in the 1980s and 1990s, a new generation of scientists began to look at the Earth's core with fresh eyes and ask uncomfortable questions. These researchers came from diverse backgrounds, not just geology and geophysics, but also from engineering, systems theory, and information science. They were accustomed to thinking about design systems, about machines and mechanisms built to perform specific functions. When they looked at the Earth's core, they saw not a random accumulation of iron and rock, but something that looked suspiciously like an engineered system, a carefully designed machine built to generate a magnetic field and maintain planetary habitability for billions of years. They began to ask whether the puzzles in the traditional geological explanation might actually be evidence of design, of deliberate construction and engineering. One of the pioneers of this new way of thinking was a geophysicist named Thomas Gold, who worked at Cornell University and had a reputation for controversial but often prescient ideas. Gold had made important contributions to astronomy, correctly predicting the properties of pulsars before they were discovered, and had proposed radical ideas about the origin of oil and natural gas in the Earth's crust. In the early 1990s, Gold turned his attention to the Earth's core and wrote a series of papers pointing out the statistical improbability of Earth having such a perfectly suited core by chance. He calculated the odds that a random planetary formation process would produce a core with the right size, composition, rotation rate, and cooling rate to maintain a stable magnetic field for billions of years. The odds were vanishingly small, less than 1 in 10 million according to his estimates. Gold argued that scientists needed to seriously consider the possibility that the core had been deliberately engineered, either by an advanced ancient civilization on Earth or by extraterrestrial visitors who modified the planet to make it suitable for life. Gold's ideas were met with intense skepticism and even hostility from the mainstream scientific community. His colleagues accused him of abandoning rigorous science in favor of wild speculation, of proposing unfalsifiable hypotheses that could never be proven or disproven. How could anyone test the idea that the Earth's core was engineered when we could not even send probes down to study it directly? The deepest hole ever drilled into the Earth, the Kola superdeep borehole in Russia, reached only about 7.5 miles down, less than 1/500th of the distance to the outer core. We had better direct observations of the surfaces of distant planets than we had of our own planet's core. Without direct evidence, Gold's critics argued, the engineering hypothesis was nothing more than an untestable fantasy, no better than ancient creation myths. But Gold was undeterred by the criticism. He pointed out that scientists routinely inferred the properties of things they could not directly observe, from the interiors of stars to the conditions in the first moments after the Big Bang. The key was to look for indirect evidence, for signatures that would distinguish an engineered core from a natural one. He suggested several lines of investigation that might provide such evidence. First, scientists should look for precision in the core's properties beyond what random chance would produce. If measurements showed that the core parameters were not just adequate but optimal for magnetic field generation, that would suggest deliberate tuning. Second, researchers should look for anomalies that made sense from an engineering perspective but not from a geological one, such as unexpected symmetries or regularities in the core's structure. Third, scientists should examine whether the core showed signs of active maintenance or self-regulation, behaviors that would indicate it was not just a machine left running, but a system still being tended or controlled. While Gold worked on the theoretical side, other researchers began to gather observational data that seemed to support his radical hypothesis. In 1996, a team of seismologists led by Xiaodong Song and Paul Richard at Columbia University published a stunning paper showing that the inner core's rotation rate was not constant but varied over time. Sometimes it spun faster than average, sometimes slower, but it always returned to an average rate of about 1 degree per year faster than the surface. This variation suggested some kind of feedback mechanism, something that sensed the rotation rate and made adjustments to keep it within a certain range. Natural systems generally do not show this kind of stable cycling around a set point. That is a characteristic of engineered systems with feedback control, like the cruise control in a car that adjusts the engine speed to maintain a constant velocity, or the thermostat in a house that turns the heating on and off to maintain a constant temperature. Even more intriguing data came from studies of the magnetic field itself. In 1997, a team of researchers analyzing satellite measurements of Earth's magnetic field discovered something unexpected. Buried in the complex pattern of the field were subtle regularities, mathematical relationships between different components of the field that had no obvious natural explanation. The field had more symmetry than it should have had if it were purely the product of chaotic convection in the outer core. When the researchers ran computer simulations of natural geodynamic processes, they could not reproduce these symmetries without carefully choosing very specific initial conditions and parameters. But if the core had been engineered, if someone had deliberately designed the flow patterns in the outer core to produce a stable magnetic field, then these symmetries made perfect sense. They were exactly the kind of thing an engineer would build into a system to make it more efficient and stable. Around the same time, another line of evidence emerged from an unexpected source. Geochemists studying the composition of ancient rocks found something puzzling in the ratios of different isotopes of certain elements. When radioactive elements decay, they produce specific isotopes of other elements at predictable rates. By measuring these isotope ratios in old rocks, geochemists can determine when the rocks formed and what conditions existed at the time. But some of the isotope ratios did not make sense according to standard models of Earth's formation and evolution. The ratios suggested that the Earth's interior had been much hotter in the past than the models predicted, hot enough to partially melt the entire mantle. This should have been catastrophic for any life on the surface. Yet the geological record showed that life had persisted continuously for billions of years. How could this be explained? One possibility was that the heat had been released in a controlled way, perhaps through some mechanism in the core that regulated heat flow to prevent catastrophic overheating. This too sounded more like an engineered safety system than a natural process. As the evidence accumulated, a small but growing number of scientists began to take the engineering hypothesis seriously. They formed informal working groups and organized conferences to discuss the idea and to plan research projects that might provide more definitive tests. They faced enormous obstacles, not just the technical challenges of studying the inaccessible core, but also the sociological resistance from a scientific community deeply invested in the conventional story of natural planetary formation. To suggest that the Earth's core might be engineered was to challenge fundamental assumptions about geology, about the history of life, about humanity's place in the universe. If the core was engineered, who had engineered it? When had it been done? Why? These questions led inevitably into territory that many scientists found uncomfortable, territory that overlapped with speculation about ancient advanced civilizations, about extraterrestrial intervention in Earth's history, about the possibility that humanity itself was not the first intelligent species to arise on this planet. Despite the controversy, research continued, and in the early 2000s, a series of discoveries added fuel to the fire. In 2002, a team of French geophysicists studying the detailed structure of the inner core using a new technique called seismic tomography, which created three-dimensional images of the interior similar to medical CT scans, found evidence of large-scale structures within the inner core. These were not random variations in density or composition, but organized patterns, geometric arrangements that looked almost artificial. The inner core appeared to have regions of different properties arranged in concentric layers, like an onion, with the innermost layer showing particularly unusual characteristics. The seismic waves passing through this innermost region behaved in ways that did not match any known natural iron structure. They traveled too fast in some directions and too slow in others, suggesting the presence of materials or structures that should not exist under the extreme pressures and temperatures of the inner core. In 2005, another bombshell dropped when a team of Japanese researchers published evidence that the inner core might contain not just iron, but also significant amounts of silicon, oxygen, and even lighter elements like hydrogen. This was unexpected because scientists had assumed that these lighter elements would be excluded from the inner core as it crystallized, floating up into the outer core instead. But if the inner core did contain these lighter elements, it raised questions about how they got there and why they stayed. One possibility was that the inner core had not formed gradually through natural crystallization, but had been assembled quickly, perhaps even instantaneously, trapping lighter elements that would normally have escaped. This scenario made no sense from a geological perspective, but made perfect sense if the core had been manufactured, built as a single unit rather than grown over millions of years. The plot thickened further in 2008 when researchers studying tiny variations in the length of the day discovered something extraordinary. The Earth's rotation rate is not perfectly constant, but varies slightly over time due to various factors like the gravitational pull of the Moon and Sun, the redistribution of mass as glaciers melt and sea levels change, and the exchange of angular momentum between different layers of the Earth. Scientists could measure these variations with incredible precision using atomic clocks and radio telescopes observing distant quasars. When they analysed decades of such measurements, they found a subtle but unmistakable pattern. The rotation rate of the surface varied in a way that was correlated with changes in the magnetic field, with a time lag of about 6 years. This meant that something in the core was sensing changes in the magnetic field, and then, 6 years later, making adjustments that affected the rotation rate of the entire planet. This was a clear example of a feedback loop, a hallmark of engineered control systems. By 2010, the accumulating evidence had convinced a significant minority of geophysicists that something very strange was going on in the Earth's core, even if they were not ready to fully embrace the engineering hypothesis. The scientific literature began to fill with papers describing anomalies, unexpected observations, and phenomena that did not fit neatly into the standard model. The mainstream geological community tried to explain away these anomalies with increasingly complex and ad hoc modifications to the natural formation theory, but the explanations were starting to seem forced and contrived. It was reminiscent of the situation in astronomy before Copernicus, when astronomers added ever more complicated epicycles to the Earth-centered model of the solar system to account for the observed motions of the planets, when a much simpler explanation was available if they were willing to abandon their preconception. The breakthrough that would finally force the scientific community to confront the engineering hypothesis came in an unexpected way, not from studying the core directly, but from examining ancient human artifacts and historical records. In 2012, a team of archaeologists excavating a site in Turkey discovered a cache of clay tablets dating to about 7,000 years ago, long before the Sumerian civilization. The tablets contained what appeared to be technical diagrams and mathematical formulas written in a previously unknown script. It took cryptographers and linguists several years to partially decode the script, but when they did, they found something astonishing. The tablets described a great mechanism at the center of the world, a device that maintained balance and stability, a machine that channeled the fire of creation to protect the world above. The descriptions included specific details about the size and shape of this mechanism, about the materials it was made from, about the energy sources that powered it. When scientists compared these ancient descriptions to modern measurements of the Earth's core, the match was eerily close. The ancient tablets described a core structure that matched the observed properties of Earth's actual core far better than any random guess could account for. At first, many scientists dismissed the tablets as elaborate fakes, modern forgeries created to support fringe theories, but extensive testing of the clay, the ink, and the archaeological context confirmed that the tablets were genuinely ancient, dating to the 7th millennium before the Common Era. This meant that people living 7,000 years ago, long before the development of modern science, somehow knew detailed information about the Earth's deep interior, information that humanity would not rediscover until the 20th century. How could this be possible? The conventional explanation was that the tablets represented lucky guesses or symbolic mythology that happened to match reality by coincidence, but the level of detail and accuracy made this explanation seem implausible. The tablets even included numbers that, when properly interpreted, matched the observed rotation rate of the inner core and the strength of the magnetic field. It was as if the ancient people who created these tablets had direct knowledge of the core's engineering, as if they were describing something they knew existed rather than imagining something from myth or legend. The discovery of the ancient tablets galvanized the scientific community and led to a new wave of research. If ancient peoples had knowledge of the core's engineering, perhaps there were other historical records that contained similar information. Researchers began combing through ancient texts, religious scriptures, and archaeological artifacts from cultures around the world, looking for references to the Earth's interior. What they found was remarkable. From China to Egypt, from India to Mesoamerica, from Mesopotamia to the Andes, ancient cultures had preserved stories and symbols that seemed to describe an engineered core. The consistency of these accounts across cultures that had no known contact with each other was striking. They used different metaphors and symbols, but the underlying concept was the same. Something powerful and purposeful existed at the center of the Earth. Something that had been placed there deliberately to maintain the world and protect life on the surface. One of the most intriguing discoveries came from analysing the Great Pyramid of Giza in Egypt. The pyramid had been studied for centuries, and researchers had long been puzzled by certain features of its design that seemed to have no practical purpose. The internal chambers and passageways were arranged in complex geometric patterns that did not make sense for a simple tomb. But when researchers compared the proportions and ratios in the pyramid's design to the known properties of the Earth's core, they found multiple matches. The ratio of the pyramid's height to its base perimeter was close to the ratio of the Earth's radius to its circumference, a relationship known since ancient times. But more remarkably, the ratio of the volumes of different internal chambers matched the ratio of the volumes of the inner core, outer core, and mantle. The angles of the passageways corresponded to important angles in the Earth's magnetic field geometry. It was as if the Great Pyramid had been designed as a three-dimensional model or symbol of the Earth's engineered interior, a monument preserving knowledge about the core's construction for future generations. Similar patterns emerged from studying other ancient monuments and sacred sites around the world. Stonehenge in England, the Nazca Lines in Peru, the temples of Angkor Wat in Cambodia, the pyramids of Teotihuacan in Mexico, all showed geometric and numerical relationships that matched properties of the Earth's core and magnetic field. Some researchers proposed that these sites were part of a global network of monuments built to preserve core engineering knowledge, and perhaps to serve some functional purpose related to monitoring or maintaining the core's operation. This idea, while speculative, gained credibility from the fact that many of these sites were located at points that formed geometric patterns on the globe, patterns that aligned with features of the Earth's magnetic field. The accumulating historical and archaeological evidence complemented the geophysical anomalies and forced many scientists to reconsider their assumptions. By 2015, several prestigious research groups had published papers arguing that the engineering hypothesis deserved serious scientific investigation rather than automatic dismissal. They pointed out that science had been wrong about fundamental questions before. The existence of tectonic plates was once considered ridiculous. The idea that continents moved was dismissed as impossible until the evidence became overwhelming. Perhaps the same thing was happening with the Earth's core. Perhaps the evidence for engineering had been there all along, but scientists had been unable to see it because it contradicted their worldview. The question then became not whether the core might be engineered, but how such engineering could have been accomplished and by whom. This led to several competing theories, each with its own supporting evidence and its own challenges. The first theory, which became known as the ancient terrestrial civilization hypothesis, proposed that an advanced human or humanoid civilization had existed on Earth hundreds of thousands or millions of years ago, long before recorded history. This civilization had developed technology far beyond what we possess today, and had engineered the Earth's core, either to repair damage from some catastrophe or to deliberately modify the planet to make it more suitable for life. This civilization had then disappeared, perhaps destroyed by the very catastrophe they had tried to prevent, perhaps departing the planet for reasons unknown, leaving behind only the engineered core and scattered remnants of their knowledge preserved in the myths and monuments of later cultures. This theory had the advantage of explaining the ancient knowledge found in texts and monuments. If an advanced ancient civilization had existed, they could have passed down information about the core's engineering through oral traditions and symbolic teachings that eventually became the myths and legends recorded in ancient writings. The theory also explained why the core appeared to be maintained and regulated. Perhaps the ancient civilization had built automated control systems into the core, artificial intelligence or self-regulating mechanisms that continued to operate long after their creators disappeared. The main challenge for this theory was the lack of direct physical evidence for such a civilization. If they were advanced enough to engineer the core, they would have left other traces, cities and machines and artifacts. Yet no such evidence had been found, despite extensive geological and archaeological surveys. Proponents of the theory argued that millions of years would be enough to erase most traces of even an advanced civilization, especially if they had deliberately removed evidence of their existence, or if geological processes like subduction had carried their cities down into the mantle where they would be destroyed. The second major theory was the extraterrestrial intervention hypothesis. This proposed that beings from another world, perhaps another star system, had visited Earth billions of years ago when the planet was young and lifeless. These extraterrestrial engineers had modified the Earth's core, installing a geodynamo system that would generate a stable magnetic field and maintain planetary habitability for billions of years. Their goal was to prepare Earth as a garden world, a place where life could arise and evolve, perhaps as an experiment, perhaps as a future home, perhaps for reasons we cannot comprehend. After completing their work, the extraterrestrial engineers departed, leaving the planet to develop on its own. But they or their descendants maintained contact with Earth throughout its history, occasionally returning to check on their project and to provide knowledge to emerging intelligent species. This would explain the ancient accounts of gods or beings from the sky who possessed advanced knowledge and who taught early humans about the structure of the world. This theory had the advantage of explaining the apparent age of the core's engineering. If extraterrestrials had modified the core billions of years ago, that would account for the fact that Earth has had a magnetic field for as long as life has existed on the planet. The theory also explained the extraordinary sophistication of the core's design. An extraterrestrial civilization, millions of years more advanced than humanity, would possess the knowledge and capability to manipulate planetary interiors, something that seems impossible with our current technology, but might be routine for them. The challenges for this theory were similar to those facing any extraterrestrial hypothesis: the lack of direct evidence for alien visitation, and the difficulty of explaining why advanced extraterrestrials would invest enormous resources in engineering Earth's core. Proponents argued that the direct evidence might exist but might not be recognized as such, or might be hidden in places we have not yet explored, such as on the far side of the moon or in deep ocean trenches. As for motivation, they suggested that an advanced civilization might undertake such projects for the same reasons that humans might someday terraform Mars or establish colonies around other stars, to spread life through the universe, to conduct long-term experiments in planetary engineering, or simply because they could. The third major theory was perhaps the most radical and the hardest for scientists to accept. This was the directed panspermia and planetary engineering hypothesis, which proposed that the Earth itself was an engineered construct from the beginning, not a naturally formed planet, but an artificial world built by unknown intelligences for unknown purposes. According to this theory, what we think of as the natural formation of Earth from the solar nebula 4.5 billion years ago was actually a construction process, a deliberate assembly of matter into a planet-sized machine designed to support life. The core was not added to an existing planet, but was the starting point, the seed around which the rest of the planet was built. This theory drew on certain puzzling facts about Earth's formation. such as the apparent collision with a Mars-sized body that formed the Moon, an event that seemed almost too convenient because it gave Earth the exact rotation rate and axial tilt needed for stable climate and seasons. It also drew on the observation that Earth seemed remarkably well suited for life, with just the right mass, just the right distance from the Sun, just the right composition, as if fine-tuned for habitability. Critics of this theory pointed out that it simply pushed the question back one level. If Earth was artificially constructed, who constructed it, and where did they come from? The theory seemed to require an infinite regress of engineering engineers. Proponents responded that perhaps the universe itself was an engineered construct, created by some ultimate intelligence that existed outside space and time, and that engineering at every level from subatomic particles to galaxies was the fundamental nature of reality rather than an exception to it. This moved the discussion into philosophical and theological territory that made many scientists uncomfortable, but it could not be dismissed out of hand. After all, the more humanity learned about physics, the more the universe appeared to be fine-tuned, with physical constants and laws that seemed almost perfectly chosen to allow for the existence of matter, stars, planets, and life. By 2020, the debate over the Earth's core had become one of the most intense and controversial topics in science. Major research institutions devoted significant resources to core studies, deploying networks of seismometers around the globe to create ever more detailed images of the interior. Satellites measured subtle variations in Earth's gravitational and magnetic fields, looking for anomalies that might reveal hidden structures in the core. Supercomputers ran increasingly sophisticated simulations of core dynamics, testing whether natural processes could account for the observed properties or whether engineering provided a better explanation. The scientific literature was filled with papers arguing for and against the engineering hypothesis, with data and counter-arguments flying back and forth in a vigorous debate that attracted public attention and sparked widespread fascination. The public response to the idea of an engineered core was mixed. Some people embraced it enthusiastically, seeing it as confirmation of ancient wisdom and spiritual teachings about the living Earth. Environmental movements incorporated the concept into their messaging, arguing that if the Earth's core was engineered to support life, humanity had an even greater responsibility to protect the surface environment and not interfere with the planetary systems. Other people reacted with fear or anxiety, worried about the implications of living on a world whose very foundation might be artificial, might be controlled by unknown intelligences, might even be turned off someday if humanity failed to meet some unknown criteria. Religious communities grappled with how the engineering hypothesis fit with their theological frameworks. Some saw it as compatible with belief in a creator God who used advanced means to accomplish divine purposes. Others saw it as a threat to faith and materialistic explanation that left no room for the sacred. Science fiction writers and filmmakers had a field day with the concept, producing a wave of novels, movies, and television shows exploring the implications. What if the engineers returned? What if the core started to malfunction? What if humanity discovered a way to access the core and found not just a machine, but something more? Perhaps an intelligence, perhaps a message left by the builders. These fictional explorations served a useful purpose, allowing society to collectively imagine possibilities and work through the philosophical and emotional implications of living on an engineered world. Some of the scenarios explored in fiction even inspired real scientific research, as scientists realized that certain fictional scenarios made testable predictions about what evidence we should look for, or what experiments we could perform. The breakthrough that would move the question from speculation to hard science came in 2023 with a remarkable technological achievement. The team of Japanese and American engineers announced that they had developed a new type of probe capable of surviving the extreme conditions of the deep Earth. The probe used revolutionary materials that could withstand temperatures exceeding 10,000 degrees and pressures millions of times greater than at the surface. It was small, about the size of a grapefruit, and packed with sensors that could measure temperature, pressure, magnetic fields, chemical composition, and seismic activity. The plan was to deploy the probe by dropping it into a deep borehole, then allowing it to sink under its own weight, melting through rock by using a small nuclear reactor to generate intense heat at its leading edge. Telemetry would be sent back to the surface using ultra-low frequency radio waves that could penetrate thousands of miles of rock. The first probe, named Orpheus 1 after the Greek hero who descended into the underworld, was deployed in 2024 at a site in the Pacific Ocean where the Earth's crust was relatively thin. The probe began its descent, transmitting data continuously as it sank deeper and deeper into the Earth. For the first time in human history, we had direct measurements from the deep mantle, and the data was fascinating. The probe confirmed many theoretical predictions about temperature and pressure, but also revealed surprises. The mantle was more heterogeneous than expected, with layers and structures that suggested complex convection patterns. As the probe descended past 1,000 miles, past 1,500 miles, approaching the boundary between the mantle and the outer core, the tension mounted. Would the probe survive the transition into the liquid outer core? Would it be able to transmit data from that depth? At a depth of 1,850 miles, Orpheus 1 crossed the core mantle boundary and entered the outer core. The telemetry showed a sudden jump in temperature and a change in the material properties, confirming that the probe had reached the liquid iron. But then something unexpected happened. The probe's magnetometer, which measured the magnetic field, started showing readings that did not make sense. The field strength was varying in a regular pattern, pulsing with a frequency of about 1 cycle per second. Natural convection currents in the outer core should have produced a chaotic, irregular field at this scale. But the probe was detecting a signal with a clear repeating pattern. Even more remarkable, the pattern was not random noise, but appeared to have structure, almost like a code or a message. The scientists monitoring the data were stunned. They ran every possible analysis to rule out instrument malfunction or interference, but the signal persisted, clear and undeniable. As Orpheus 1 continued to descend, sinking deeper into the outer core, the signal became stronger and more complex. The probe's other sensors were also detecting anomalies. The chemical composition of the outer core was not uniform but varied in organized patterns. The temperature was not smoothly increasing with depth, but showed layers where it remained nearly constant, as if something was regulating it. The pressure readings showed subtle variations that correlated with the magnetic field pulses. All of this pointed to active processes in the core, to mechanisms and structures that were doing something beyond just passively conducting heat and generating magnetic fields through natural convection. At 2,500 miles deep, well into the outer core, Orpheus 1 made a discovery that would change everything. The probe's seismic sensors detected a solid object nearby, something that should not exist in the liquid outer core. As the probe drifted closer, its sensors revealed that this was not a small chunk of solid material, but a massive structure extending in all directions beyond the probe's detection range. The structure appeared to be made of an unknown material, not iron or any familiar rock, with properties unlike anything in the scientific database. It was conducting electricity, generating a powerful localized magnetic field, and was hundreds of degrees cooler than the surrounding liquid core, as if it was actively cooling itself. The probe had discovered something artificial, something that could only be described as a machine or a device, sitting in the Earth's outer core, 2,000 miles below the surface, operating for unknown purposes. The discovery sent shockwaves through the scientific community and captured the world's attention. Orpheus 1 had found direct, undeniable evidence that something engineered existed in the Earth's core. The probe transmitted data for 3 more hours, mapping out more of the mysterious structure, before its systems began to fail under the extreme conditions and it went silent. But those 3 hours of data were enough. Scientists analysing the information concluded that the structure was enormous, possibly thousands of miles across, perhaps even forming a complete shell around the inner core. It appeared to have multiple components or layers, each serving different functions. Some parts seemed designed to regulate heat flow, others were generating and shaping magnetic fields, still others appeared to be sensing conditions and making adjustments. It was a machine of stunning complexity and sophistication, operating autonomously in an environment where no human technology should be able to survive. And it had been there for billions of years, maintaining Earth's habitability, keeping the magnetic field stable, protecting life on the surface. The immediate question was who had built it and why. The age of the structure could not be directly determined from the probe data, but geological evidence suggested the Earth's core had been in its current configuration for at least 3.5 billion years, possibly since the planet formed. This meant the structure was ancient beyond comprehension, built by intelligences that existed long before humanity, possibly long before any life existed on Earth's surface. The level of technology required to build such a structure and place it in the core was staggering. It would require the ability to manipulate matter and energy on a planetary scale, to work in environments of unimaginable temperature and pressure, to design systems that would operate reliably for billions of years. This was technology that seemed almost godlike compared to human capabilities. Yet it existed, hidden in the depths of our planet, operating in silence and darkness, fulfilling its purpose without acknowledgement or recognition. The discovery of the core structure forced a complete re-evaluation of Earth's history and humanity's place in the universe. If the core was engineered, then Earth itself was not a natural world but an engineered habitat, deliberately designed to support life. This raised profound questions about the origin and purpose of life on Earth. Did life arise naturally on this engineered world, or was it also part of the plan, seeded here intentionally by the same intelligences that built the core? If life was seeded, what was its purpose? Were we being grown like crops in a garden, cultivated for some harvest we could not imagine? Or were we an experiment, a test to see what forms intelligence might take when given billions of years to evolve on a stable, protected world? Or perhaps we were meant to be heirs, inheritors of the engineered world, destined to eventually discover the core's secrets and take over its maintenance, becoming the new caretakers of Earth. Scientists and philosophers debated these questions intensely. Some argued that the engineering of the core did not fundamentally change anything about the human condition. We were still the product of evolution, still the result of billions of years of natural selection shaping our biology and behavior. The core simply provided the stable conditions needed for that evolution to occur. Our thoughts, our emotions, our societies, our art and music and literature were still authentically ours, not programmed or dictated by the core's engineers. Others argued that the engineering of the core meant we could not truly know whether anything about human nature was genuine or engineered. Perhaps the engineers had designed not just the core but the entire evolutionary process, setting up conditions that would inevitably lead to the emergence of a certain kind of intelligence with certain traits. Perhaps what we thought of as free will was actually the unfolding of a program written billions of years ago. These debates echoed ancient philosophical arguments about determinism and free will, but now with the added dimension of potential external design. Religious thinkers offered varied interpretations of the core discovery. Some theologians saw the engineered core as evidence of divine creation, arguing that God worked through natural-seeming mechanisms, and that the core structure was simply the means by which divine will maintained the earth. Others saw the discovery as challenging traditional religious narratives and forcing a more expansive view of creation that included other intelligences and other methods beyond the simple fiat creation described in scriptures. Still others saw no conflict at all, arguing that the question of who engineered the core simply pushed the ultimate question of creation back one level. whether the engineers were themselves created by God or were aspects of the divine creative force manifesting in the universe. The practical implications of the core discovery were also profound. If the core was a machine, it might require maintenance, it might malfunction. It might even be controlled or modified if humanity could develop the technology to access it. Some scientists and engineers began to seriously discuss the possibility of sending more probes to the core, more sophisticated versions of Orpheus 1 that could not only observe but interact with the core structure. Perhaps we could learn to communicate with it, to understand its design and purpose. Perhaps we could even repair it if something went wrong. But others warned against such hubris, arguing that we were nowhere near understanding the technology we were dealing with, and that attempting to tamper with the core could have catastrophic consequences. The core had been maintaining Earth's habitability for billions of years without human help. Who were we to think we could improve on its operation or modify its function? The debate over whether to continue core exploration and potentially interfere with the core structure became a major political and ethical issue. International bodies were formed to discuss and regulate core research. Treaties were proposed to govern what kind of experiments could be performed and what safeguards needed to be in place. Some nations wanted to push forward aggressively, seeing the core as the ultimate technological prize, a source of knowledge and power that could revolutionize civilization. Others advocated extreme caution, arguing that the core should be declared off-limits to human interference, a sacred trust that we were obligated to leave untouched. Environmental and spiritual movements organized mass protests against core exploration, with demonstrators carrying signs reading, "Leave the heart alone," and "The core is not ours to touch." Meanwhile, some commercial interests saw opportunities, proposing wild schemes to tap the core's energy, or to use the core's magnetic field for advanced propulsion systems. While these debates raged, scientists continued to analyze the data from Orpheus 1 and to plan future missions. The data revealed more details about the core structure that deepened the mystery even as it answered some questions. The structure appeared to have multiple redundant systems, backup mechanisms that would take over if primary systems failed. This suggested a design philosophy focused on reliability and longevity, which made sense if the goal was to maintain the core's operation for billions of years. The structure also showed signs of self-repair capability. Parts of it appeared to be newer than others, as if they had been replaced or regenerated over time. This implied that the structure was not just a passive machine, but had some form of active maintenance system, either automated or possibly controlled by an intelligence residing within the core itself. This last possibility, that there might be an intelligence in the core, became a major focus of speculation and research. Some of the magnetic field pulses detected by Orpheus 1 showed patterns that seemed too complex to be merely mechanical operations. Researchers trained artificial intelligence systems to analyze these patterns, looking for anything that might be language or information encoding. The results were tantalizing but inconclusive. Some patterns did show statistical properties consistent with information encoding, but whether this was intentional communication, data storage, or just the complex operations of the core machinery was impossible to determine from the limited data available. The idea that humanity might be living on a planet with an alien intelligence at its heart, an intelligence that had been there all along, silently maintaining our world, was both thrilling and terrifying. What would such an intelligence think about us? Was it aware of life on the surface? Did it care about humanity? Or were we merely an incidental consequence of its operations, like bacteria growing in a machine? The core discovery also sparked renewed interest in exploring other planets and moons in the solar system to look for similar engineering. If Earth's core was engineered, were the cores of other worlds natural? Or had the same engineers modified other planets as well? Missions were planned to study the interiors of Mars, Venus, Jupiter's moon Europa, and Saturn's moon Titan, looking for signs of engineered structures. Some scientists speculated that Mars might once have had an engineered core like Earth's, but that it had failed or been deactivated, causing the planet to lose its magnetic field and atmosphere and become the dead world we see today. Perhaps studying Mars could reveal what happens when a planetary engineering project fails, providing crucial lessons about how to maintain Earth's core in the future. As the 21st century progressed, the question of the Earth's engineered core became one of the central issues shaping human civilization. It influenced everything from science and technology to philosophy and religion, from politics and economics to art and culture. Schools taught children about the core structure alongside traditional geology, explaining how the Earth was both a natural world shaped by geological processes and an engineered system maintained by ancient technology. Universities established new departments devoted to studying planetary engineering and to developing the technologies that might someday allow humanity to create or modify planetary cores ourselves. Young people grew up with the knowledge that their world was designed, that they lived on an engineered planet, and this shaped their worldview in profound ways. Some found it comforting, a reminder that the universe was not entirely random and chaotic, that intelligence and purpose existed on scales greater than human civilization. Others found it unsettling, a reminder of how small and insignificant humanity was in the larger cosmic picture, how we were potentially just guests on a world built by others for purposes we could not fathom. The discovery also changed how humanity viewed its future. If our world was engineered, perhaps it was our destiny to become engineers ourselves, to learn from the core's design and to eventually build new worlds, to spread life through the galaxy by creating habitable planets around other stars. This vision inspired a new generation of scientists and explorers, people who saw humanity's future not as confined to Earth but as expanding outward, carrying forward the work of the ancient engineers who had made Earth a haven for life. Space agencies developed ambitious plans for missions to nearby star systems, hoping to find planets that could be engineered, that could be given cores like Earth's and transformed into new homes for life. The timescales for such projects were enormous, centuries or millennia, but that no longer seemed impossible. If the core's engineers could build systems that operated for billions of years, humanity could learn to think on similar timescales. At the same time, the core discovery prompted a new appreciation for Earth and a renewed commitment to protecting it. If our planet was a unique, engineered marvel, then destroying its surface environment through pollution, climate change, and ecosystem destruction was not just foolish but sacrilegious. The environmental movement gained new urgency and moral authority, arguing that humanity had a responsibility to honor the work of the core's engineers by maintaining the surface environment in a state that could support life. This perspective helped drive global efforts to transition away from fossil fuels, to restore damaged ecosystems, and to establish protected areas where nature could thrive without human interference. The idea took hold that humanity was the conscious, intelligent component of the Earth system, the part that could make deliberate choices, and that our responsibility was to work in harmony with the engineered core to maintain the planet's habitability. As research into the core continued, scientists made additional discoveries that refined their understanding of the core structure and its operation. Follow-up probes, more advanced than Orpheus 1 and designed to last longer in the core environment, revealed that the core structure was even more complex than initially thought. It consisted of multiple layers and subsystems, each performing different functions. The outermost layer appeared to be primarily sensors, monitoring conditions throughout the core and in the mantle above. The middle layers contained what could only be described as processors, or control systems, analyzing data from the sensors and making adjustments to the core's operation. The innermost layer, closest to the solid inner core, appeared to be power generation and heat management, drawing energy from the radioactive decay of elements in the core and from the gradual cooling of the planet, then distributing this energy to power the core's systems and to drive convection in the outer core. Even more fascinating, the The probes detected what appeared to be conduits or channels running through the core structure, tubes or pathways through which material flowed in carefully controlled patterns. Analysis suggested these conduits were moving specific elements or compounds to different parts of the core, perhaps to maintain the chemical composition needed for optimal magnetic field generation, perhaps to deliver fuel or nutrients to different systems, perhaps to remove waste products or worn components. This was logistics and supply chain management on a planetary scale. A distribution network embedded in the core that ensured all parts of the system received what they needed to function. The sophistication of this network was breathtaking, and scientists studying it began to see parallels with biological circulatory systems or with the information and resource networks in modern cities. The core was not just a machine but a system, an integrated whole where every part worked together to achieve the common goal of planetary habitability. One of the most intriguing questions was how the core structure powered itself. The probes detected energy sources throughout the structure, but the total energy budget seemed higher than could be accounted for by known processes like radioactive decay or heat from the planet's formation. Scientists proposed several possibilities. Perhaps the core was tapping into quantum vacuum energy, extracting power from the underlying structure of space-time itself. Perhaps it was using some form of fusion, combining lighter elements in the core to produce energy and heavier elements as byproducts. Perhaps it was even drawing energy from another dimension or from some exotic physics we had not yet discovered. Whatever the energy source, it was clearly sufficient to power the core's operations for billions of years and potentially for billions more, suggesting that the engineers had solved the fundamental problem of long-term power supply that had plagued human technology since the Industrial Revolution. As humanity approached the mid-21st century, the implications of living on an engineered world had become fully integrated into global consciousness. New generations had grown up knowing the truth about the core, and for them it was simply a fact of existence, not a shocking revelation. But the questions remained. Who were the engineers? Where were they now? Why had they built the core? And perhaps most importantly, what did they want from us? Some researchers believed that the answers to these questions might be encoded in the core structure itself, that the engineers might have left messages or instructions for any intelligent species that eventually arose on Earth and discovered the core's secrets. Teams of cryptographers and linguists worked on analyzing the patterns in the core's magnetic field and the arrangement of its components, looking for anything that might be a message. So far, no clear communication had been found, but the search continued, driven by the hope that contact with the engineers, even across billions of years, might be possible. Others believed that the engineers were still watching, that they had not abandoned Earth but maintained some presence, either in the solar system or perhaps even on Earth itself, observing humanity's development and waiting for us to reach a certain level of understanding or capability before revealing themselves. This belief led to speculation about UFO sightings and mysterious phenomena as potential evidence of the engineers' ongoing presence. While mainstream science remained skeptical of such claims, the discovery of the engineered core had opened minds to possibilities that would have been dismissed out of hand in earlier times. If ancient intelligences had engineered Earth's core, then perhaps they were still around, still influencing events in subtle ways. The line between science and speculation had become blurred in ways that made some scientists uncomfortable, but that others saw as a necessary expansion of what science could consider. By the year 2050, humanity had sent dozens of probes into the core, building up a detailed map of its structure and a comprehensive understanding of its operation. The core was now recognized as the most sophisticated machine ever discovered, a technological achievement that far surpassed anything humans had built. Scientists from all disciplines studied it, not just geophysicists, but also engineers, computer scientists, biologists, and even artists and philosophers. all trying to understand different aspects of its design and to draw lessons applicable to human endeavours. The core had become a teacher, a source of knowledge about how to build systems that could last for geological timescales, how to design for resilience and reliability, how to work with nature rather than against it. Many technological breakthroughs in human society were directly inspired by principles observed in the core's design. At the same time, ethical questions about human interaction with the core had become more pressing as technology advanced to the point where active intervention became possible. Engineers had developed probes that could not just observe, but manipulate, capable of making small adjustments to the core's systems or testing hypotheses about how different components worked. Some scientists argue that such active experimentation was essential for understanding, and that as long as changes were small and carefully controlled, the risks were acceptable. Others maintained that any interference with the core was unacceptably dangerous, that we still did not understand the system well enough to predict the consequences of even small changes. This debate came to a head when a proposal was made to adjust one of the core's feedback systems to slightly increase the strength of Earth's magnetic field, which had been slowly weakening over the preceding centuries. Proponents argued that this weakening might be a sign of aging in the core structure, and that human intervention could prevent a collapse of the magnetic field that would be catastrophic for life on the surface. Opponents argued that the weakening might be a normal fluctuation or even an intentional adjustment by the core's own systems, and that human interference could disrupt a delicate balance and cause exactly the catastrophe it was meant to prevent. The debate became a defining moment for human civilization, forcing society to confront fundamental questions about our relationship with the planet and our level of technological maturity. Were we ready to take on the role of planetary engineers, to assume responsibility for maintaining the core and managing Earth's geophysical systems, or should we continue to leave the core alone, trusting that the ancient engineers had designed systems robust enough to handle any contingency? Different nations, cultures, and philosophical traditions gave different answers, reflecting deeper values about humanity's relationship with nature and technology. After years of debate, an international agreement was reached that allowed limited, carefully monitored experimentation with non-critical core systems, but forbade any changes to the primary magnetic field generation or heat regulation systems without unanimous consent from all nations and a showing of clear necessity. This compromise satisfied neither the advocates of aggressive intervention nor the proponents of complete non-interference, but it provided a framework for moving forward that most could accept. As the century progressed, the focus of core research gradually shifted from basic science toward more practical applications. Engineers developed new materials inspired by the core structure's ability to survive extreme conditions. Energy researchers studied the core's power generation systems, hoping to develop fusion reactors or other advanced energy sources for human use. Computer scientists analyzed the core's control systems, learning principles of robust, self-healing computation that led to major advances in artificial intelligence and autonomous systems. Biologists studied how the core maintained itself over billions of years without outside repair, drawing lessons about longevity and self-repair that had applications in medicine and life extension. In countless ways, the core became a wellspring of innovation, driving human technological advancement forward at an accelerating pace. Yet even as humanity mastered more of the core's principles and developed increasingly sophisticated technology, the central mystery remained unsolved. Who had built the core? The question had no answer. Only speculations and theories, each with its own body of circumstantial evidence, but none with proof. The ancient terrestrial civilization theory remained popular, supported by the ancient texts and monuments that seemed to preserve knowledge of the core. Advocates of this theory continued to search for more direct evidence, excavating sites around the world and analyzing geological formations for signs of advanced ancient technology. The extraterrestrial intervention theory had its own adherents, who pointed to the sophistication of the core's design as evidence of an intelligence far more advanced than ancient humans could have been. They organised efforts to search for other traces of extraterrestrial visitation in the solar system, examining the Moon, Mars and asteroids for artefacts or structures. The directed panspermia theory remained the most radical and the least testable, but it gained some support from physicists studying the fine-tuning of the universe's physical constants, and from philosophers considering the implications of infinite universes and anthropic reasoning. Perhaps the most significant development came not from Earth-based research, but from humanity's expanding presence in space, as colonies were established on the Moon and Mars, as mining operations extracted resources from asteroids, as probes were sent to the outer solar system and beyond. Humanity gained new perspectives on planetary formation and on the possibilities of planetary engineering. Studies of other worlds in the solar system found no evidence of engineered cores like Earth's. Mars, Venus, Mercury, the moons of Jupiter and Saturn all appeared to have natural, unmodified interiors. This suggested that Earth was unique, at least in our solar system, strengthening the argument that it had been specially selected and modified by the engineers. But it also raised questions. If the engineers were capable of modifying planetary cores, why had they only done so for Earth? Was there something special about our planet, some property that made it the ideal candidate for their project? Or had they modified other worlds as well, perhaps around other stars, and Earth was just one of many engineered planets scattered through the galaxy? This question inspired the expansion of humanity's search for engineered worlds beyond the solar system. New space telescopes were built specifically to study the interiors of exoplanets, using gravitational waves and other indirect methods to probe their cores. The search was difficult because the signatures of an engineered core were subtle and hard to distinguish from natural variation, but scientists persevered, developing increasingly sophisticated techniques. By the end of the 21st century, several candidate exoplanets had been identified that showed anomalies consistent with engineered cores. These worlds became priority targets for interstellar probes, and eventually for crewed missions as humanity developed the technology for faster-than-light travel. The hope was that by finding and studying other engineered worlds, humanity could finally answer the question of who the engineers were and what their ultimate purpose had been. Meanwhile, back on Earth, society had been profoundly transformed by the knowledge of the engineered core. The discovery had sparked a renaissance in science and technology, but also in philosophy, religion, and the arts. Writers, artists, and musicians explored themes of creation and purpose, of the relationship between the created and the creator, of what it meant to live on a world that was both natural and artificial. New religious movements emerged that revered the core as divine, or that saw the engineers as gods or angels. Traditional religions adapted their theologies to incorporate the core, with some seeing it as confirmation of their teachings and others seeing it as a challenge requiring reinterpretation. Philosophers debated the implications for human meaning and purpose, with some arguing that the engineered nature of our world made human life more meaningful because we were part of a cosmic plan, and others arguing it made life less meaningful because we were not truly free, but were fulfilling a role assigned by the engineers. These debates were not merely academic, but had real impacts on how people lived their lives. Some individuals found new purpose in studying the core and advancing human knowledge, seeing themselves as continuing the work of the engineers. Others found purpose in protecting the Earth's environment, seeing themselves as stewards of the engineered world. Still others turned away from the material world entirely, focusing on spiritual development and seeking direct contact with the intelligence they believed resided in the core or with the engineers they hoped were still watching. Society became more diverse in its worldviews and values, but also more unified in the recognition that humanity faced challenges and opportunities that required collective action and global cooperation. As the 22nd century dawned, humanity stood at a crossroads. We had uncovered the secret at the heart of our world, and and had begun to understand the technology that had sustained life for billions of years. We had developed the capability to maintain and perhaps even improve the core's operation, to take over the role of planetary engineers from the ancient builders. But we also recognized the awesome responsibility this capability entailed and the potential consequences of mistakes or hubris. The question was no longer whether the core was engineered, but what humanity would do with that knowledge. Would we be worthy inheritors of the engineered Earth, or would we prove ourselves unfit for the responsibility? Would we learn from the engineer's example and use our growing power wisely, or would we repeat the mistakes that might have destroyed previous civilizations? These questions could not be answered by science or technology alone, but required wisdom, foresight, and a profound commitment to the long-term flourishing of life on Earth and beyond. The core had given humanity a gift. Not just the stable environment that had allowed our species to evolve, but also a challenge and an opportunity. The challenge was to rise to the level of the engineers, to develop the knowledge, capability, and wisdom needed to maintain and eventually improve the planetary systems we depended on. The opportunity was to become a spacefaring civilization that could spread life through the galaxy, engineering new worlds and starting the evolutionary process on planets that would otherwise remain barren. This was a vision of humanity's future that was both humbling and inspiring, a reminder that we were part of something larger than ourselves, participants in a cosmic story that had begun billions of years ago and would continue long after our individual lives ended. In the early decades of the 22nd century, the first attempts were made to apply the principles learned from the Earth's core to engineering the core of Mars. Mars had once been a living world with liquid water on its surface and possibly even life, but had lost its magnetic field billions of years ago, probably due to the cooling and solidification of its core. Without a magnetic field, the solar wind had gradually stripped away the Martian atmosphere, leaving behind the thin, cold, dry atmosphere we find today. If humanity could restart Mars's core, could create an artificial geodynamo like Earth's, the planet could be protected from the solar wind and the process of terraforming could begin in earnest. It was an audacious project, requiring the ability to drill down hundreds of miles into Mars's interior and to emplace nuclear devices or other energy sources that would reheat the core and start it convecting again. It would take centuries to complete, but the potential payoff was a second living world in the solar system, a backup for humanity in case something went wrong with Earth. The Mars Core project became a testing ground for humanity's abilities as planetary engineers. Teams of scientists and engineers from around the world collaborated on the design, drawing on the best understanding of core dynamics gained from decades of studying Earth's core. The technical challenges were immense. Mars was smaller than Earth, which meant its core was smaller and had cooled more quickly. Simply reheating it would not be enough. An artificial system would need to be built, a miniature version of Earth's engineered core, capable of generating and maintaining a magnetic field for millions of years. This meant not just installing power sources, but also creating the complex control systems, sensors, and self-repair mechanisms that made Earth's core so robust. It was a project that would take multiple human lifetimes to complete and would require resources on a scale never before mobilized. But it was also a project that unified humanity, giving people a common goal that transcended national boundaries and political divisions. As work on the Mars project progressed, research continued on Earth's core, with new discoveries still being made. One of the most startling findings came in the year 2135, when a probe exploring the innermost regions of the core structure discovered what appeared to be a message. It was not encoded in language or symbols, but in the physical structure of the core itself. Certain components were arranged in patterns that, when mapped out, formed a three-dimensional image. It took years of analysis to fully decode the image, but when it was finally understood, it showed a map of the galaxy with certain star systems marked. Scientists realized they were looking at a chart, a guide to other engineered worlds. The engineers had left directions, showing humanity where to look for other planets with modified cores, other worlds prepared for life. The discovery changed everything. It confirmed that Earth was not unique, that the engineers had worked on many worlds, and it provided humanity with specific targets for exploration and eventually colonization. The star systems marked on the core map became the destinations for humanity's first interstellar missions. Faster-than-light technology, developed in the late 21st century by scientists inspired by studying the exotic physics possibly at work in the core's power systems, made such journeys feasible within human lifetimes. Ships were built and crews were selected, the best and brightest from all nations. People who would spend years or decades travelling to distant stars to investigate worlds that might have been engineered like Earth. The first of these missions launched in 2142, a fleet of 5 ships heading to 5 different star systems, each between 20 and 50 light-years from Earth. The crews knew they were embarking on journeys of discovery that would reshape humanity's understanding of its place in the universe. They carried with them not just scientific instruments, but also the hopes and dreams of billions of people who watched their departure and waited anxiously for news from the stars. Over the following decades, as these ships made their long journeys, and humanity continued to study Earth's core and to work on the Mars project, a profound shift occurred in human consciousness. The knowledge that our world was engineered, that we were potentially part of a galaxy-spanning project of planetary modification and life cultivation, changed how people thought about meaning and purpose. The old debates about whether the universe was meaningless or purposeful, whether existence was absurd or filled with significance, took on new dimensions. Clearly, there was purpose at work on the scale of planets and solar systems, even if the ultimate source and goal of that purpose remained mysterious. Its realization did not answer all philosophical questions, but it did provide a framework within which those questions could be addressed with new perspectives. The first of the interstellar missions reached its target in 2187. The star was a sun-like yellow dwarf, and the planet was a world slightly larger than Earth, orbiting in the habitable zone where liquid water could exist on the surface. The ship's instruments detected a strong magnetic field, far stronger than would be expected for a planet of that size. As the crew deployed probes and began detailed surveys, they confirmed what everyone had hoped to find. The planet had an engineered core with a structure remarkably similar to Earth's. The world had continents and oceans, an oxygen-rich atmosphere, and complex ecosystems. Life had arisen here, as it had on Earth, and had evolved to fill every niche, from microbes to megafauna. But there were differences too. The life on this world used different biochemistry, suggesting it had evolved independently, rather than being seeded from Earth. The engineers, it seemed, had prepared multiple worlds and allowed evolution to take its course on each one, producing a diversity of life forms across the galaxy. The discovery of this second engineered world, which the crew named New Terra, was a triumph for humanity and a vindication of the core map's accuracy. It proved that the engineers' project was vast, spanning many light years and involving many worlds. Over the following years, the other interstellar missions reached their targets and found similar results. Of the 5 star systems marked on the core map, 4 had planets with engineered cores and thriving biospheres. The 5th system had a planet with an engineered core, but the surface was a frozen wasteland. Geological evidence suggested that the planet had once been warm and living but had suffered some catastrophe, perhaps an impact by a large asteroid or a nearby supernova, that had frozen its oceans and killed its biosphere despite the still functioning core. This dead world was a sobering reminder that even the best engineering could not protect against every possible disaster, and that maintaining life on a planet required not just a functioning core, but also luck and perhaps active management. These discoveries from the interstellar missions inspired a new wave of research into the engineer's identity and purpose. With multiple engineered worlds to compare, scientists could look for patterns and commonalities that might reveal the engineers' methods and goals. One striking pattern was the age of the engineered cores. Dating of the cores on different planets showed that they had all been built at approximately the same time, roughly 4 billion years ago, give or take a few 100 million years. This suggested a coordinated effort, a campaign of planetary engineering carried out across many star systems in a relatively short period of galactic time. The scale of resources and organization required for such a campaign was mind-boggling. The engineers must have had a vast industrial capacity, probably far exceeding anything humanity could imagine even with our most optimistic projections for future development. They must have had faster than light travel and the ability to work on many worlds simultaneously. They must have had a deep understanding of biology and evolution, to design cores that would maintain conditions suitable for the emergence of complex life over billions of years. But who were they? The question remained unanswered. No artifacts had been found on any of the engineered worlds beyond the cores themselves. If the engineers had visited the surfaces of these planets, they had left no ruins, no machines, no trash, nothing that would indicate their presence, except the cores deep below. This suggested several possibilities. Perhaps the engineers had worked entirely from space, never landing on the planets they modified. Perhaps they had been careful to leave no trace on the surfaces, deliberately erasing evidence of their presence. Or perhaps they were so advanced that what seemed like artifacts to them were indistinguishable from natural objects to us. Their technology so sophisticated that we could look right at it and not recognize it as artificial. Some researchers proposed a radical idea. What if the engineers were not physical beings at all, but were instead some form of advanced artificial intelligence or digital consciousness? Such entities might have no need for physical bodies or structures in the traditional sense. They might exist as information patterns, residing in quantum computers or other exotic substrates, manipulating matter and energy through mechanisms we had yet to discover. This would explain the lack of artifacts. It would also explain the engineers' apparent ability to work on many worlds simultaneously, as digital consciousnesses could potentially exist in many places at once, or could communicate and coordinate instantaneously across vast distances. While this idea was speculative, it gained support from physicists studying the information theoretic aspects of the core structures, who found evidence suggesting that the cores might be implementing some form of quantum computation in addition to their other functions. As humanity entered the 23rd century, our relationship with the engineered core of Earth had matured. The initial shock and wonder had given way to a deeper understanding and appreciation, as the core was no longer an alien mystery, but was becoming a known quantity, its operation documented and understood in increasing detail. Humanity had taken on the role of active caretakers, with engineers making small adjustments to maintain optimal function as the core systems aged. The Mars core project was nearing completion, with the first successful generation of a stable magnetic field expected within a decade. Plans were underway to begin similar projects on Venus and on large moons in the outer solar system, expanding the number of habitable worlds under human management. And the interstellar missions had returned with knowledge of other engineered worlds, providing both destinations for future colonization and laboratories for studying the engineers' work in different contexts. Yet even with all this progress, fundamental questions remained. The discovery of the engineered cores had answered some questions about the Earth's nature and about the prevalence of life in the galaxy, but it had raised even deeper questions about the universe itself. If the engineers had worked on dozens or hundreds or thousands of worlds, preparing them for life, then the galaxy might be full of living worlds, many of them with intelligent civilizations that had also discovered their engineered origins. Why had we not encountered any of these other civilizations? The old Fermi paradox, the question of where all the aliens were, took on new dimensions in light of the engineered cores. If life was common and engineered, then intelligent life should also be common. Yet the radio telescopes and other search programs had found no signs of extraterrestrial civilizations, no signals, no evidence of large-scale engineering projects in other star systems beyond the cores themselves. Several explanations were proposed for this new paradox. Perhaps the engineers had designed the cores to produce life, but had also implemented some mechanism to prevent civilizations from becoming too advanced, or from spreading too far, keeping each world isolated so that the galaxy remained a garden of diverse but separate evolutionary experiments. Perhaps the timescales of civilization were shorter than the timescales of planetary engineering, and most civilizations destroyed themselves or collapsed before they developed the technology to communicate across the stars. Perhaps other civilizations were out there but were deliberately staying quiet, following some galactic protocol of non-interference until humanity reached a certain level of development. Or perhaps the engineers themselves were still active, monitoring the worlds they had seeded, and they prevented civilizations from making contact until they deemed both parties ready. These questions, while fascinating, remained purely theoretical, matters for speculation and debate rather than empirical investigation, but they shaped how humanity thought about its future and its responsibilities. If we were alone, or at least isolated from other civilizations, then we had a duty to preserve and spread life, to honor the work of the engineers by continuing it. If other civilizations existed but were hidden, then we needed to prepare for eventual contact, to develop our society and our wisdom to the point where we could meet our cosmic neighbors as equals. And if the engineers were still watching, still active in the galaxy, then everything humanity did might be part of a test or a learning process, and we needed to prove ourselves worthy of the gift they had given us. By the middle of the 23rd century, humanity had established a presence on multiple worlds in the solar system and had sent expeditions to several nearby star systems. The terraforming of Mars was well underway, with the engineered core maintaining a protective magnetic field and the atmosphere slowly thickening as gases were released from subsurface reservoirs and as comets were diverted to crash into the planet, delivering water and volatiles. Within another century or two, Mars would have liquid water on its surface again and would be ready for the introduction of engineered organisms to begin building a biosphere. Similar projects were planned for other worlds, each one a multi-century undertaking that required unprecedented cooperation and long-term planning. These projects were humanity's way of honoring the legacy of the engineers, of taking on the responsibility of planetary stewardship and life cultivation that the engineers had demonstrated was possible. At the same time, research into the Earth's core had reached new levels of sophistication. Permanent stations had been established at various depths, some as deep as 1,500 miles, using technology that created stable cavities in the rock and allowed scientists to work in what would otherwise be an instantly lethal environment. These stations conducted experiments, made detailed observations, and maintained the sensors and probes that monitored the core's operation. The data from these efforts had given humanity an almost complete picture of how the core functioned, how the engineered structure maintained itself, how it sensed and responded to conditions throughout the planet. But there was still one mystery that remained largely unsolved, one question that had puzzled researchers from the beginning. How did the core communicate with the inner core, and what determined the precise rotation rate that the inner core maintained? The answer came in 2268 from an unexpected source. A team of quantum physicists studying entanglement and non-local correlations realized that some of the mathematical patterns they were seeing in their laboratory experiments matched patterns that had been observed in the core's magnetic field. They proposed that the core structure might be using quantum entanglement to coordinate its operations, that components separated by thousands of miles might be instantaneously connected through quantum channels, allowing for coherent operation of the entire system without time delays or signal transmission. This was a radical idea because quantum entanglement was not supposed to work on large scales at high temperatures. Yet the core somehow maintained quantum coherence even in the inferno of the deep Earth. If this hypothesis was correct, it had profound implications. It meant the engineers had mastered quantum information science to a degree far beyond current human capabilities. It also suggested a possible answer to how the core communicated with the inner core and regulated its rotation. The inner core might be quantum entangled with the core structure, receiving information about the state of the outer core instantaneously and adjusting its rotation accordingly. This would explain the precise feedback control that had been observed. Over the following years, experiment confirmed that quantum entanglement was indeed present in the core, detectable in subtle correlations between magnetic field fluctuations in widely separated regions. This discovery opened up new avenues of research, both for understanding the core better and for developing new quantum technologies inspired by the engineers' methods. As the 3rd century of the modern era, the period after the discovery of the engineered core, approached, humanity had become a different species in many ways. We were no longer bound to a single world, but were spreading through the solar system and beyond. We had become planetary engineers ourselves, taking on the responsibility of maintaining and creating habitable worlds. We had unlocked many of the secrets of the Earth's core and were applying those lessons to improve human technology and society. And we had embraced our identity as the inheritors of an ancient legacy, as the current chapter in a cosmic story that began billions of years ago when unknown engineers decided to prepare Earth and other worlds for life. The knowledge of our engineered origins had not diminished humanity, but had elevated us, giving us a sense of purpose and connection to something greater than ourselves. Yet even with all this progress, the central mystery remained. We still did not know who the engineers were. We had not found them or made contact with them. We had not discovered their ultimate purpose or learned why they had undertaken the enormous task of engineering planetary cores across the galaxy. We had only their works to study, magnificent and mysterious, operating in silence in the depths of countless worlds. Perhaps someday we would find answers to these questions. Perhaps the engineers had left more than just cores and star maps. Perhaps there were messages or repositories of knowledge hidden elsewhere, waiting to be discovered by civilizations that reached the right level of development. Or perhaps the engineers themselves would return, emerging from wherever they had gone, to check on their gardens of life and to meet the intelligences that had arisen on the worlds they had prepared. Until that day came, if it ever did, humanity had a clear path forward. We would continue to study the core, to learn from its design and to maintain its operation. We would continue to spread through the galaxy, finding other engineered worlds and establishing ourselves as a multi-planetary species. We would continue to develop our technology and our wisdom, striving to become worthy of the legacy we had inherited, and we would continue to wonder about the engineers, to search for clues about their identity and their purpose, to hope that someday we might understand why they chose to invest such effort in creating havens for life across the cosmos. These goals would occupy humanity for centuries or millennia to come, providing meaning and direction to our collective endeavour as a species. The story of the Earth's engineered core was, in the end, a story about perspective and humility. For most of human history, we had seen ourselves as the pinnacle of creation, the most important thing in the universe, the end point of a natural process that had no purpose beyond producing us. The discovery that our world was engineered, that we existed because of the deliberate actions of intelligences far beyond our own, was initially a blow to human pride. We were not the centre of the story, but were characters in someone else's narrative. Yet this realization, once accepted, became a source of wonder and inspiration rather than disappointment. We were part of something larger, part of a cosmic project of extraordinary scope and ambition. Our existence was not an accident, but was made possible by careful planning and sophisticated engineering, and now we had the opportunity to carry that project forward, to become engineers ourselves, to create new worlds and to cultivate new forms of life, to add our own chapter to the cosmic story that the ancient engineers had begun. As you drift now into deeper sleep, let your mind rest with this thought. Beneath you, beneath the soil and the stone, beneath the oceans and the mountains, beneath everything you know, there spins a crystal heart, ancient and powerful, engineered with purpose and maintained with precision, generating the invisible shield that protects you, that protects all life. That makes possible the green growing world and the blue sky and the warm sun on your face. You live on a world that was made, carefully designed and lovingly maintained for billions of years, and that fact, strange as it may seem, is a reminder that intelligence and purpose exist in the universe. That creation is an ongoing process, and that you are part of that process, a small but significant thread in the vast tapestry of cosmic time. Sleep now, knowing that you rest on a living world, an engineered marvel spinning through space, a home prepared for life by hands unknown, maintained by systems beyond our complete understanding, but familiar now, no longer frightening but comforting, a reminder that we are not alone, that we are not accidents, that we are children of a universe far stranger and more wonderful than we ever imagined, inheritors of an ancient gift, participants in a story that reaches back billions of years and will continue for billions more. A story of life and intelligence spreading through the cosmoses, of worlds prepared and civilizations arising, of mysteries discovered and wonders unveiled, of humanity taking its place among the stars, carrying forward the work of the engineers who made our existence possible, honoring their legacy by becoming creators ourselves, by spreading life and intelligence and wonder throughout the galaxy, by ensuring that the great project of planetary engineering and life cultivation continues generation after generation, world after world, till perhaps someday we meet the engineers themselves or become indistinguishable from them. Master builders of worlds, tenders of the cosmic garden, keepers of the ancient knowledge, maintainers of the engineered cores that make life possible, participant in the greatest story ever told, the story of how intelligence arises from matter, how life spreads through the void, how meaning emerges from chaos, and how the universe comes to know itself through eyes and minds that arose on worlds carefully prepared for that very purpose. Worlds like Earth, our home, our engineered world, spinning in space with its crystal heart beating in the darkness, a beacon of life in the cosmic night, a testament to what is possible when intelligence sets itself to the task of creation, a reminder that we are part of something vast and ancient and ongoing, and that our future, like our past, is connected to forces and purposes beyond our full comprehension, but no longer beyond our participation, no longer beyond our ability to honor and to continue, no longer beyond our reach as we grow in knowledge and capability, as we spread through the stars, as we become the engineers of new worlds, as we add our chapter to the eternal story, the story that has no end, the story of life and mind in the universe, the story whose next pages are ours to write, beginning here, on this engineered world we call home, this planet with a heart of crystal and iron, this earth, our cradle, our school, our inheritance, our responsibility, our gift to the future, spinning forever in the darkness, protected by the magnetic field generated in the depths, maintained by systems that have operated for billions of years and will operate for billions more, ensuring that life continues, that consciousness persists, that the universe remains awake to itself, aware of its own existence, capable of wonder and discovery and creation, capable of love and hope and dreams, dreams like the one you are entering now, where all things are possible, where the mysteries of the cosmos unfold in your sleeping mind, where you too become an engineer of worlds, a creator of realities, a dreamer whose dreams shape the universe, whose sleep is filled with visions of what could be, of what will be, of what must be, as humanity moves forward into its cosmic destiny. as we spread through the galaxy, as we discover other engineered worlds and other civilizations, as we finally learn who the engineers were and what they intended, as we perhaps meet them, or become them, or surpass them, as we write the next chapter in the greatest story ever told, the story that begins with a crystal heart spinning in darkness and ends with intelligence and life spreading through the cosmos, filling the universe with consciousness and purpose, transforming the void into a garden, the darkness into light, the silence into song, the emptiness into fullness, the mystery into revelation, one world at a time, one generation at a time, forever and always, without end. As long as the engineered cores continue to spin, as long as the magnetic fields continue to protect, as long as life continues to flourish on worlds prepared for that purpose by ancient hands, as long as new intelligences arise to carry forward the great work, as long as the cosmic story continues to unfold, page after page, chapter after chapter, world after world, star after star, into the infinite future that awaits, the future that begins with understanding where we came from, with appreciating the gift we were given, with accepting the responsibility that comes with knowledge, with honouring the legacy of the engineers by becoming worthy of it, by growing in wisdom and compassion and capability, by spreading life and joy and meaning through the cosmos, by ensuring that the great project continues, that the engineered worlds remain maintained, that new worlds are prepared for new forms of life, that the universe becomes ever more alive, ever more conscious, ever more filled with purpose and meaning, as intelligence spreads and grows and evolves, as we move from being the children of the engineers to being their peers and perhaps their successors, as we take on the mantle of cosmic gardeners, as we become the ones who prepare worlds for life, who build cores that will operate for billions of years, who leave messages for future civilizations, who participate fully in the cosmic dance of creation and evolution and consciousness, who fulfill the potential that was built into us from the beginning, written into our DNA by 4 billion years of evolution on an engineered world, encoded into our mind by millions of years of cognitive development, embodied in our civilization by thousands of years of cultural evolution, and now brought to fruition as we stand on the threshold of our cosmic destiny, ready to step forward into the galaxy, ready to take our place among the stars, ready to become the engineers, ready to add our voice to the cosmic symphony, ready to write our chapter in the eternal story, the story that has no ending, the story of life in the universe, the story of consciousness awakening to itself, the story of intelligence spreading through the cosmos, the story of worlds engineered and civilizations arising, the story of mystery and discovery and wonder, the story that is yours to live and to tell, the story that continues even as you sleep, even as you dream, even as you rest here in the comfort of night, knowing that beneath you the crystal heart continues to beat, the ancient machine continues to operate, the engineered core continues its work, maintaining the field that protects you, sustaining the world that nurtures you, the future that is vast and bright and full of possibility, the future that begins now, here, with understanding, with appreciation, with wonder, with sleep, with dreams, with rest, with peace, with the knowledge that you are part of something greater, that you are connected to a cosmic story, that you are an inheritor of an ancient legacy, that you are a participant in the ongoing creation of the universe, that you matter, that your existence has meaning, that you are here for a reason, that the world you live on was prepared for you by ancient engineers who worked for purposes you can only begin to understand, who left you a gift beyond measure, who gave you a living world with a crystal heart, who made possible everything you are and everything you will become, who started a story that is now yours to continue, yours to honor, yours to carry forward into the infinite future one day at a time, one discovery at a time, one dream at a time, beginning now, in this moment, in this sleep, in this peace, in this rest, as you float in the space between waking and sleeping, between knowing and mystery, between past and future, between earth and stars, between human and cosmic, between sleeping and dreaming, between one breath and the next, between heartbeats, in the eternal now, the present moment that contains all of time, all of space, all of existence, all of story, all of meaning, all of life, all of consciousness, all of creation, all focused here now, in you, in this moment, in this sleep, complete and whole and perfect, exactly as you are, exactly as the universe intended, exactly as the universe intended, forever and always, without beginning or end, circular and eternal, like the crystal core spinning in the depths, like the earth spinning in space, like your thoughts spinning in the darkness, spinning slower now, quieter now, deeper now, into rest, into peace, into sleep, into dreams, into the place where all stories begin and end, where all mysteries are revealed, where all purposes are fulfilled, where all journeys find their destination, where all questions find their answers, where all wonders unfold in endless profusion, where you are home, where you have always been home, where you will always be home, here on this engineered world, this living planet, this cosmic garden, this gift from ancient hands, this earth, our home now and forever, spinning in darkness, protected by an invisible fields, sustained by an engineered heart, maintained by ancient systems, home to humanity, home to life, home to consciousness, home to wonder, home to you, now, here, in sleep, in peace, in rest, in dreams, forever. You